Alright, so, Trig fans, we have just a little bit left over from section 4.3 to take notes on. This is the floating, oddly shaped Ferris wheel, similar to the one found in example 5 in the book. It has a radius of 17. The center is 22 feet from the ground. So what we want to know is, how high is the seat off the ground as you travel around? How high is the seat off the ground? So every one of these points, right, you'll notice that there are 12 spokes to this Ferris wheel. So if we can think of this like a unit circle except with a radius of 17, then each one of these, this would be considered pi. Each one of these would be pi over 6, right? 2 pi over 6, right? Because if there's 12 of them, then you're cutting pi into 6 pieces. And this would be 2 pi over 6, and 3 pi over 6, and 4 pi over 6, and 5 pi over 6. Oops, can't write. And 6 pi over 6, and 7 pi over 6, and 8 pi over 6, and 9 pi over 6, and 10 pi over 6, and 11 pi over 6. And then eventually you're right back to the beginning, which is 12 pi over 6. Now obviously some of these can be reduced, right? You know, you can reduce this one to pi over 3, pi over 2, 2 pi over 3. So we could go around the circle and we could reduce several of these. Okay, but if you want to split a circle into increments of pi over 6, that is the simplest way to do it, is to just go around. Now, every coordinate on this circle, we know it has an x value and a y value. Now, each one of those x's and y's we know has an angle measurement theta. Right? The theta represents the angle of rotation. So we talked about how the coordinate xy could be written as cosine theta, comma, sine theta. Which one of those parts is important to figuring out the height? Is it the x value, which would be the distance from here to here, or the y value, the distance from here to here? Well, I would agree it's the y value that we're interested in. Now, if you want to find the location at this spot, you've got this distance right here, plus this distance, which is all the way down to the ground, and we know that that's to be 22 feet, right? 17 for the radius and an extra 5 feet. Because the Ferris wheel is floating above the ground. Interestingly enough, you have to jump up to get on the Ferris wheel, so that creates a little bit of a problem for different people to get on the Ferris wheel. Something to do with magnetism. I'm not sure exactly how it all works, but just floats right there in the air. So let's see here. We have the sine of theta plus 22 feet. Now, it's not just the sine of theta, because remember, we're dealing with a radius which is no longer 1. So, how does that change if the radius is now 17? Well, each one of these coordinates is now no longer just cosine theta, sine theta. No, it's 17 cosine theta, comma, 17 sine theta. Because you have multiplied everything by 17. So how high is the seat off the ground? Well, the vertical distance is now 17 sine theta. Well, I gotta remember what I'm writing here. Plus, we also have this 22 feet all the way down. So that is the height that you are above the ground. Basically, the y value plus 22 extra feet. how high are you at the top? Well, what's the radian measure at the top? Isn't that pi over 2? You figure out what the sine of pi over 2 is. At 2 pi over 3. At 4 pi over 3. Now these, I will tell you this, you need a calculator for these two. You will right now. Now later I will ask you to do it without a calculator. Alright, but for today, we'll use a calculator. This one, however, up here, you should actually know without a calculator at all. Now, at 2 pi over 3, which is right here, 17 sine 2 pi over 3 is a positive number, and then you add 22 more feet to get down to the ground. But at 4 pi over 3, which is here, this distance is actually a negative distance, right? Because it's below the x-axis. So when I add the 22, that takes me down, and then I get this piece from here to here. So when you have rotated underneath that x-axis, this value for 17 sine theta is actually negative. Well, that makes a whole lot of sense because we talked about how y values underneath the x-axis were negative because sine goes with the y value. So this actually right here will be a negative number. And then when you add it to the 22 feet, you'll end up with a positive height, but it'll be a lot, it'll be a lot closer to 5, which is at the very bottom. A couple more questions for you to answer in your notes. Find 3 values of theta that solve this question. And you need to start thinking about where cosine is actually -1 on this circle. And then I want you to name it in 3 different angle measurements, all in radians. So 3 different, and you can go around the circle as many times as you need to. You can go around in different directions, but think about it, okay? Next question. As theta increases from 0 to pi over 2, does cosine theta increase or decrease? I want you to think about what cosine theta is, and as you go from 0, a radian measure of 0, to a radian measure of pi over 2, so that's from a measurement of 0 all the way up to pi over 2. Tell me what's happening to the cosine of theta. Now, I recognize, I thought a couple of you knew or remembered the area and circumference formulas for circles. A couple of you, I think, need some help, so I thought I would give you a little bit of assistance on this. Here's how I remember. Pi r squarea. Yep, that's my formula for the area. Pi r squared, right? Pi r squared. We know that pi's are square. They're not round. So, cherry, apple, raspberry, strawberry. Those good ones. Oh, lemon meringue. Okay, so to peer in the distance. Now, I know you can't, just imagine somebody with their hand, holding it up like I'm doing right now, but you can't really see it. I'm holding my hand up on my forehead. I'm looking over towards the bulletin board on the side where my tractor is, a picture of the old tractors, and a picture of the one that looks like my tractor, and that dude walking up the escalator with the ocean. I know it looks weird. But then look over there and say, to peer in the distance. That's the same thing, right? To peer in the distance. Oh, look, there it is. 2 pi r. Distance is the circle around. It's going around like circumference. 2 pi r. Yeah, I know that was a little bit of a stretch, but hopefully that helps you. Anyway, we need to go on to section 4.4. The basic trig identities for sines, cosines, and tangents of doom. Yes, Mr. Ducker, that was for you. So, let's see here. We've got the unit circle. We've got every coordinate on the unit circle has an x and a y value, a cosine and a sine. And what happens when you take the x and square it and the y and square it and add those together? Don't you get the 1 squared, which is just 1 for those of you who were wondering, which is the same thing as cosine theta squared plus sine theta squared equals 1, better known as the Pythagorean identity. Ha 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 ha. And how can we use that? Well, if you know an x value, but you don't know the y value, right, such as the example that you see below, we can use this theorem. So cosine theta, I'll just write it out again so we can see it on screen right now, so you're not complaining. So let's see here, 3/5 squared plus sine theta squared equals 1. Notice that I did not say theta was 3/5. I said the cosine of theta was 3/5. So I see kids that make mistakes and they say cosine 3/5, and I'm like, no, that's not what we're talking about. Okay, so if I square that, that's 9 over 25, right? So I'm going to subtract 9 over 25 to the other side without a calculator. So that gives me sine theta squared equals, holy cow, how do you subtract 1? Or how do you do 1 minus 9/25 if you don't have a calculator? Keep in mind that 1 is 25 over 25, so that when I subtract this, I end up with what? 16 over 25? Right? And then I take my square root and my square root, and the sine of theta is then plus and minus 4/5. Yeah, you don't know whether theta, the original angle, is in what quadrant it's in, so your y value could be positive 4/5 or negative 4/5. See, the only thing they told me in the beginning of the problem was, they told me that the x value was 3/5. That's about 0.6. So they told me that the x value was 3/5. Okay? All right, here's about 0.5, so 0.6 is a little bit farther than that. But they didn't tell me, and so the angle theta could be here, or the angle theta could be all the way around there. In either case, you'd have a negative y value here, and you'd have a positive y value there. So I don't know whether sine is positive 4/5 or negative 4/5. They didn't tell me enough information. I'd have to be more specific so that you would know for sure. Okay, opposites theorem. There are a few different theorems we need to go around the circle and understand. The opposites theorem. So on my slightly poorly drawn unit circle, we've got the angle theta, and we've got negative theta, right? Those are opposite angles from each other. So let's see here. We got a point x, y. So what do you think? Do you think that this point and this point down here have the same x value or opposite x values? And the answer is they have the same x's. Remember, cosine is the x value. What do you think about the y values? We have a y value here and a y value here. Do you think they're the same y values or opposite y values? That's right, they are opposite y values. That's your sine function, right? So the sines of opposites are opposites. What do you think about the slopes? Slopes, are they the same or are they opposites? They are opposites. I should say opposite slopes. And that goes with tangents, right? So if we had something like this, let's give a pi over 6. The opposite angle for that would be negative pi over 6, right? The cosine of pi over 6. Suppose I told you that was radical 3 over 2. What would you know about the cosine of negative pi over 6? Wouldn't it be exactly the same? Suppose I told you that the cosine, the sine of pi over 6 was 1/2. What would you know about the sine of negative pi over 6? So the y value here is 1/2. What's the y value here? Negative 1/2. The tangent of pi over 6. Well, that's slope, right? That's the rise over the run. So that's the sine divided by the cosine. Okay, so that's 1/2 divided by radical 3 over 2, which is the same thing as 1/2 of 2 divided by radical 3. Don't forget the 2's are canceling, giving me 1 over radical 3. But what rational person would leave it like that? None that I know of. So we would write it as radical 3 over 3. So let me clean that up a little bit. Tangent pi over 6 is radical 3 over 3. What would you know about the tangent of negative pi over 6? Same or opposite? Definitely opposite. I know, you're getting a real education on fractions here. Supplements. Supplements are angles which add up to pi. I know you were going to say 180 degrees, but that's in the land of degrees. And pretty much for the rest of your life, you're going to be living in radians. So you need to get used to it, okay? Living in the world of radians. So let's see here. We have an angle theta, and pi minus theta would be right here. That's the supplement right there. It's called pi minus theta, right? Because if you took theta here and went back, right, that's the angle rotating around there. So theta and pi minus theta are considered to be supplements to each other, because when you add them together, pi minus theta plus theta, you get pi. Just like they taught you in geometry, right? I know, they talked in degrees, but now you are all grown up, and you're going to be able to talk in radians to all your friends, especially people at parties. Now, what do we know about the x values here and here? What's their relationship? Do you think the x values are the same or opposites? So they have opposite x's. What do you know about their y values? Same or opposite? They have the same y's. What about their slopes? They have opposite slopes. So that tells you everything you need to know about cosines, sines, and slope and tangents. So two angles which are supplements to each other, for example, would be pi over 6 and 5 pi over 6, because we know if you add them together, you end up with pi. So if I ask you for the, or if I tell you that the cosine of pi over 6 is radical 3 over 2, what are you going to tell me about the cosine of 5 pi over 6? So cosine here and cosine here. Well, they have to be opposites of each other. So you're just going to use the exact same logic as you kind of move around this circle, you know, for the supplements theorem. You know, I could ask you for the sine. If the sine of pi over 6 is 1/2. What's the sine of 5 pi over 6? And same logic, right? Same y's, so it would also be 1/2. If I told you that the tangent of pi over 6 was radical 3 over 3, then because the slopes are opposites, then you'd say the tangent of 5 pi over 6 was negative radical 3 over 3. Okay, then there's the half-turn theorem. Okay, half-turn is, here's theta, go around the circle to pi plus theta, right? Here's pi. You're adding an entire half circle, or pi radians. So what do we think about the x values? So we have opposite x's. Those are your cosines. We have the opposite y's. Right? And what about the slopes? Same slopes. That would be your tangents. So cosines, sines, tangents. So keep in mind, if I tell you cosine pi over 6 is radical 3 over 2, I can ask you for the cosine of 7 pi over 6, which is the half turn. In fact, you should be able to use the Pythagorean identity to come up with this one, even though you can copy it from your notes. So figure out what all of these are. Okay, the last one is your complements theorem. Your complements theorem. And this one is a little bit unusual. Whoa. Talk about a terribly drawn circle. So we got our theta here, and we have pi over 2 at the top. And if we come back theta, this one's called pi over 2 minus theta. Now complements, we remember from geometry, are two angle measurements that when you add them together add up to pi over 2. I know they said 90 degrees, but you know, they were living in a different kind of world, so we are in the world of radians, and that would be pi over 2 radians. Okay, primarily because that's rad. Okay, that was lame, but you get the point. So, let's see here. We got a point here, xy, and a point here, xy. It looks like it's a reflection across a line, y equals x. What happens when you reflect across that line, y equals x? Oh yeah, the x's and y's switch places. That sounds an awful lot like inverses. So if you call this point xy, this other point would be called yx, because the x's and the y's switch places. So x's and y's switch places. Well, what does that do to the slopes? It actually causes, if this slope is y over x, it would cause this slope to be x over y. Their relationships are reciprocals. Slopes are reciprocals. So, x's and y's switch places, slopes are reciprocals. And let's see now. So we can talk about cosine of pi over 6, sine of pi over 6, and tangent of pi over 6. And then their counterparts, right? Which would be cosine 2 pi over 6, but we'll call it pi over 3, because their relationship is that they add up to pi over 2. So take these values and apply the logic to come up with these 3 values. And I'll talk to you in class. I am really, I like the fact that you have enjoyed these 25-minute notes.